So I assume everyone's working on milestone 1, and that's why we got like a quarter of the class. So whenever we say, hey, is anyone from team X here? Everyone's like, I have never heard of the number X in my entire life, so it's definitely not me. So I'm going to try something else and say, what anyone want to tell us what you're doing? A lot of times we get feedback in this class that people wish they had a better holistic sense of what other teams are doing, just in terms of strategies being taken, the initial models, your approach to the cold start problem, So who wants to share? There's like literally no answer. I will not. Like no answer here is bad because honestly, it's not really about the model. Who wants to? What are you doing?
So we used the KNN model. Initially, we wanted to use a user. Collaborative filtering, but then we ended up not making it that strong, and then we switched to KNN.
Okay.
Just to make it simple.
Sure.
But the baseline model is basically a very complex SQL.
Okay.
Yeah.
So how are you dealing with cold start?
With cold start?
Yeah.
For cold starts, we're sending the user generated, like the plain text the user gives us, to an LLM with a list of our valid genres and saying, hey, which genres do you want? And then we use those genres to basically, we keep all of the movies that someone's watched, or the global popularity score, and basically just do a scoring metric based on those genres to get which movies to predict.
Anyone doing something else? So we're asking an LLM for genre, then doing a little bit of scoring, right? Who's doing something different? Or if you're doing the exact same thing, that's also fine.
We're using like sentence embeddings for one of the models. So we're converting the movie data and the user data into embeddings and then matching the vectors by like checking cosine similarity.
Cool. So cosine similarity. And so is that for the cold start problem or for the recommendation problem?
For the cold start and the recommendation.
Okay. Cool. Do you think it's working?
Yeah. I hope so.
So those are two very different answers, right? I love it. Were you not using an LLM for the cold start problem? It's just sentence embeddings. Okay, interesting. So I like it. Wildly different answers. All right. Well, let's talk about other things, I suppose. Like testing in production. If this is too small, it says honk if shit is falling off. Okay. So we're going to pick back up because we were talking about QA, like pipeline quality stuff, and then we were talking about deployment, the sort of a circular dependency there. But now we're going back to testing because we ended the question about testing talking effectively about unit tests and how those concepts apply to models, right, and to machine learning models and to the pipeline. But these are all testing before deployment, right? Unit tests are tests at the sort of function level. Integration testing is testing how functions or modules interact. System testing and demonstration, right? But these are all things we do before we deploy, whether it's manual or automated in CI. There's actually quite a long history of testing during deployment. This is a screenshot of Windows 95. Which was before, I assume, most of you were born. Which actually, the point here is that it went back quite a ways, this idea of trying to get early production feedback. They had a program, like a beta program, where you could opt in to receive early releases. And then the point was you're supposed to try and tell them when things were broken, right? Like beta testers, but beta testers in production, like trying to actually use the deployed product. And there's a long, long history here, right? That moved in a bit more widespread of a way to what we call crash telemetry. So here, if you've seen something like this, I don't know what the current UI looks like because I try to avoid Windows, but it's along these lines, right, where something crashed. If you're in the middle of something, please tell Microsoft about this problem. Send error report, don't send, right? Every device you've ever used has given you something like this. It also has a very long history. The idea is that some information has been collected about the crash, and the user has the option to share some of that information with the company. And the whole idea is to find bugs in production. The tricky bit, of course, under the hood is that to do that, right, we need to have been collecting data about behavior in real time. Right? Because otherwise, what are you going to say? Like, oh, it crashed. So sort of the early deployment of telemetry, collection and analysis of runtime data. But it's a little bit less continuous than the kinds of things we see today. That's kind of the sort of history spiritually, right? This goes back 40 years as an idea, and now it's very widespread and much more continuous. And that's the kind of spiritual thing we're talking about today. So we're talking specifically about assessing the model, right? Not the overall system. But we'll get to the system too. So to recap, it is important to evaluate your model offline. But the problem there is that the training and test data are inevitably drawn from the same population. And so if all you're doing is evaluating offline, both leakage and overfitting problems are quite common. And so a core question is, is the population representative of production data? And does the model generalize beyond it? Are there problems with it that we should be looking for? So the key idea about model assessment in production is live observation in the running system. And for that, you need what we call telemetry, where telemetry is automatic collection and monitoring of data on model performance, data quality, and user behavior to ensure and evaluate model accuracy, detect drift, and maintain overall system health in real time. So automatic collection of data, right? Let's not even worry about monitoring. We want to collect data of a system as it's being used. So how do we gather data in any of these? Pick one. I want to do real time. What kind of data am I collecting? I'll hand you this, go get the chocolate and come back.
For example, was the weather prediction good one? You could compare what your prediction was to what actually happened in the real world.
Where you can wait 3 days, right? You sort of have to. It's funny. I will elide my long story about how hard weather prediction is. Right, you can wait 3 days. I think that actually applies to a number of these. That, was the house price predicted correctly, right? Ultimately, you can see what the house sold for and see if you were right. What about one that doesn't involve waiting some indeterminate period of time, since that answer is now taken? Or if it's not taken, tell me which other one we can use it on.
For the Spotify playlist one, we could have user reviews to check it.
Sure, we can have user reviews for Spotify. So how do you want to ask the user for reviews?
Have a thumbs up and thumbs down.
Sure, we can give the user the option to provide feedback, thumbs up, thumbs down. Maybe that's not very intrusive, right? I liked it better when you were haggling me, because then I could have made you work.
For Spotify, I think for user preference, you can determine how long they stay for listening music, so that they can be all the.
Oh, right. We can. Yeah. So for Spotify, we can see how long they're listening. Here, pass this, and also that. That's even more. That's less intrusive if you're doing it right. Right. You're just seeing, are they continuing to listen?
For the last one, you can learn on the news if you hit a pedestrian with your car.
Yep. You can wait 3 days to make sure to see if accidents happen. It's very much a one-way test, but sure. Sure. So for ranking of search results, you can see which rank they clicked. And if you control the whole ecosystem, you can see if they're doing the same search again, if they're coming back to that page. Cookies are wonderful except for privacy. So these are a bunch of different options, right? Of different levels of intrusiveness. Just wanted to get you thinking about it. Let's talk about formalizing this a little bit. Not formalizing, but I'm going to sort of enumerate kind of the broad space of options. There is one that nobody gave me, which is kind of interesting, because it's actually quite common these days. One is to manually label, and I put manually in air quotes on purpose, production samples. Just collect a bunch of data and ask originally people if they were any good, right? So things like image recognition live, right? You could ask people. So I have Mechanical Turk on here because it was, sort of the standard for this for a while to get people to do it. It's less fashionable now for two reasons. One problem with this is that there are a lot of quality control concerns with something like Mechanical Turk. People are paid so little per task, right, and many volumes of tasks, that you need to have some kind of careful controls to make sure that they're not just like hitting A on every answer, right? And there are things you can do there. You can seed the tasks with tasks where you know the right answer and require a certain score on the overall set of tasks in order to reimburse people, right? There are lots of things people have done to try and accommodate that. But these days, there's a lot more emphasis on sort of a combination of things. Something like Surge AI or Scale AI or Labelbox are sort of trying to deal with the reliability issues that people were having with crowd working platforms like Mechanical Turk. So these kinds of companies typically have a dedicated data labeling workforce where they can sort of say, like, these are not random people. And also, the word AI is in, I think, all of their names now, obviously, because there's an increasing emphasis on using LLMs as judges to label things. And so they're combining like a sort of a suite or a framework of tools for both doing the labeling and also managing experiments and tracking model quality over time and so on. There's lots of sort of toolkits that they're doing. So I think all three of them still have dedicated human workforces, right? So we haven't totally lost that element, but there is also an increasing emphasis on using an LLM as a judge. Another strategy, which we did kind of have when we talked about the Spotify thumbs up, thumbs down thing, is just having explicit reports. These, I think, tend to more commonly have the flavor of, oh, report a problem. Right? Although you can also give teams a compliment if you're having a really weird day. This is useful for indicating some problems, except there's massive oversampling of negative feedback. And that's true in any kind of feedback mechanism where you're asking customers to provide feedback. People love to complain. And also there's sort of distribution of star rankings. People either love a thing or they hate a thing, and nobody ever is going to go out of their way to give feedback on something that's mid, right? So you have to kind of sample expectingly, right, in terms of those proportions. There are, I think, a lot of, and we're beginning to touch on this in your answers, right, of what we might call implicit feedback. So here is an example of, what's it called, transcription, right, where this has a UI that allows a person who's using it to make small changes to the transcript if it was inaccurate. And so if you do that and you're also collecting the data, you can see where the model went wrong, and you can collect that. So we saw this a bit when we were talking about search rankings, right? There's implicit collection by paying attention to what people click on. Spotify, looking at what people skip, right, versus the songs that they listen to for a while. And I think you can see some parallels to some of the things we were talking about with what I was showing you on that first dashboard, right, the movies that people watched, right? If we were paying attention to what they were watched versus what they were recommended, that's an implicit feedback mechanism for evaluating quality. And we can also, this was the first answer, wait. Right? So we can look at weather prediction by waiting 3 days. There are some, I think, obvious trade-offs here. On the one hand, you can get really accurate labels because you can look at actual reality, which is always nice as a label. What's a downside? No downsides. We should always just wait. I believe that there are no downsides to this strategy. I believe there are downsides, but I do not want to speak in front of my peers. I realize that the second one is a trap.
I think it's just too late.
Right, it can often be late, right? And if we want to do something like real-time detection of system problems, right, or real-time drift, right, in terms of, we've been talking about key system indicators and leading indicators, right? The idea is to be able to spot where we're going as quickly as possible. If you have to watch for 7 days to see if your model's going bad, like that's a long lag in the modern era. So this is sort of our key summary. I think that actually covers everything we were talking about in the examples you guys gave. Right, those are the 4. So if we want to measure model quality with telemetry, remember again, there's 3 steps of how we do measurement. I'm repeating this a lot because this is a thing that, I don't know, can often trip students up. I do encourage you to check previous midterms for example questions along these lines. Not saying there will definitely be a question that asks you to operationalize. I'm just saying, just historically, if I look over the sample of all previous midterm questions asked and the things that we practiced in class a lot.
I can say that there will definitely be a question.
You're ruining the dramatic tension. Let me remind you, telemetry can provide insights, right? It can provide very accurate label for real unseen data. Sometimes it's only mistakes, sometimes it's delayed, often it's just samples, right? But it is often sufficient to approximate precision recall or other model quality measures. And trend analysis can provide insights, right? So what we want to say is, what are we measuring? How are we collecting the data? That's telemetry. And how are we turning that data into a number? Those are the 3 steps. Breakout number 1. I have 4 scenarios. We're going to practice talking about the telemetry issue and operationalizing it into a metric. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So like from here down, here's our breaking point, okay? No, here down. Okay, my left. So you all, Amazon. So imagine that we have a shopping app that like you see someone with really cute shoes next to you in class and you take a picture and it tells you what the brand is. Imagine Google Lens, but like super narrow for a shopping app, okay? Front right, Google Photos, tagging photos with human names. They've gotten weirdly good at detecting my children as they age. It's kind of freaking me out. Back left, Spotify. Back right, automatic meeting summary from Zoom. Okay, so what's the telemetry? What are you collecting? What's the metric? What are you collecting? How are you operationalizing it? Go. I'll let those of you finish typing. And I decided Christian should be the bad guy now. So it's not just me. And he sounds like a bad guy anyway, so it's good to put him in charge. So which section's going to volunteer first?
Very back.
The very back. They have the best view in the back.
Okay. Yeah, so for if I'm not mistaken, we're doing Spotify, right? So oh, sorry, but I did Spotify anyways.
I think you were supposed to do Spotify. Yeah, that's correct. Recommending personalized playlists. So
okay.
You're doing the right thing.
Okay, great.
But if you all did something else, also fine.
No, I did the Spotify.
You did Spotify.
So like the metric would be 7-day replay or return rate of the playlist, right? If people would like it, they would go back to listen to the same playlist. And the data to collect would be like reactions, like minutes listened and stuff, or maybe the reactions of the users, like it would say to skips or early exits and go to another playlist. And operationalizations would be qualified listen would be like start and then plus or minus 5 minutes, under 5 minutes, and failure would be like exit fast or skip 10 seconds early maybe, or 15 seconds.
Okay, so one thing I think I'm noticing is maybe a disconnect between the metric, which is return to recommended playlists, and the rest, right? Unless I misheard you at the beginning, which is fine. I'm here to critique and help you grow. It's not like a problem. But I hear that you're collecting telemetry. The data you're collecting is things like, skips, how long people are listening to different songs, right? And then we can turn that into what?
So what I said for the metrics is that, how often do the users come back and listen to the same playlist?
So over what period of time?
Around 7 days.
7 days. So over a 7-day window, we are going to measure
the amount of time, or the amount of the amount of time that he comes back, or the amount of time he spends on
listening to playlists that were recommended or not, presumably.
Yeah,
okay.
That's what I meant.
Okay, I got you. No, it's okay. We already talked about Spotify briefly anyway, unless you would like to expand on Spotify. You have the microphone.
No. I mean, Spotify is maybe the closest to movie recommendations.
It's true.
But it's also personalized playlists, so not quite.
My right, so back right was Zoom automatic meeting summary. This one's, I think.
Okay, so for the we choose the rock score and the bird score to qualify our metrics for quality metrics. And
rock score of what?
Bird score.
Okay.
Yeah, so we can evaluate the meeting summary between the similarity between the meeting summary and the the human generated summary for the meeting.
Okay, so where are you getting a human generated summary?
So that's for the data to collect. We need to ask human to annotate the summaries for the meeting.
So you are hiring Labelbox to do this for you? That's an acceptable answer. I'm just trying to figure it out. Okay. So, and then we will measure agreement over time. Okay. That is one possibility, right? Telemetry strategy. I saw a bunch of different answers actually on this one, so I think having a second strategy discussed. Somebody have a different one? You can totally cop out by saying, no, ours was the same. I'm like teaching you to game my own system.
So we did the model quality metric, the number of people that enabled the AI summary feature.
Okay.
The data to collect would be the number of clicks on enabling the feature before the meeting. And the operationalization would be observe user reactions, calculate percentage of clicks and feature over total number of users of Zoom meetings across all users.
Over what period of time? Pick a number.
1 month.
Okay, great. So long as there is a number, I almost don't care what the number is. Yeah. Maybe you care, Christian. I'm just trying to remind you. Okay, so that is, it's a proxy metric, right? Do people think it's useful? So it's not so much a measure of model accuracy, but it's fine, it's a breakout, right? But it is a metric for maybe whether it's users care about it, which is kind of probably more what we care about, honestly.
It's extremely indirect.
It is very indirect.
You asked about enabling or disabling.
Yeah, we could also do disabling.
So it's much more about people believe that it's good rather than this is actually.
Right, I think I'd want to track both enabling and then disabling, because if I turn it on and then I turn it off, that's a lot more interesting than...
We could also track how many people disable it after trying it for the first time.
Over some period of time, presumably. There's a lot of proxy stuff that gets baked in there, though. Maybe you don't want all your meetings summarized.
That's true, yeah.
Hello.
Hi.
All right, so...
Feels like a game show.
For the model quality metric, we wanted to do a fixed rate. We were going to measure how often users have to correct the AI summary.
Okay.
How often they accept it as is.
Okay, so this, I think, implicitly in it has a bunch of features that you've built in, right? Which is that I present the summary to you and then offer you the opportunity to fix it in place, which is a thing that you could do. Actually, I don't know. Zoom doesn't. I've used this mostly in Teams, and I don't know if Teams does because I'm not the one who's running that meeting. I know that we copy it into Google Docs and then change it, so then you kind of run into trouble.
Microsoft wouldn't know.
No, exactly, right? And so then there's a question of, I think, careful feature design, right? I think the question is, how do you incentivize the user to use this feature that Zoom doesn't have? But OK, so that I think is a bit more direct. So I think the first answer was very much a direct measure of model accuracy, right? Because you're like, hey, we're going to give a bunch of examples to humans that we are paying to make summaries, and then we're going to check if they agree, and it's going to take forever and be expensive, but like pretty direct measure of model accuracy. Second answer, much more indirect, right? Sort of like, do the users find the feature useful enough to leave it on? Third answer, somewhere in the middle, I think. So I think it's kind of interesting. In that sense. So I think you can see there's different like layers here and different things we're kind of controlling for. Let's be complete. So shopping app, Google Lens, but for shopping. And I mean, I guess Google Shopping probably has this feature, but no one uses Google Shopping, so who cares?
So for the shoe app, so the user is going to take a picture of the shoes, and our metric is that how, like, we assume we have a database of all, like, each brand's shoes. Mm-hmm. So how accurate, how accurate is our suggestion of the shoe that matches the brand? So our metric is going to be not accuracy; it's going to be recall of all the shoes that we've suggested, which one are of this brand.
So how can you tell though that you're right?
We intend on having we intend to crowdsource that.
I see. Okay.
Yeah. So a user would we would suggest a brand, and they would either confirm and say, yeah, this is it, or reject and say, no, it doesn't look like that. And
okay, so we have a crowdsourcing option here, right? We could also, I mean, there are different ways you could do this implicitly too, right? If you make a suggestion, you could have a little like thumbs up, thumbs down under it, and you're probably going to oversample wrong, but that's still kind of useful. Yeah. Right? Because you can kind of assume.
As long as they approve or reject, we'll get their feedback somehow.
Yeah. So there's a key difference between the two strategies, right? One is live while users are using it, and one would be collect the data and then have some kind of humans do the judgment. And there are trade-offs, right? One would probably be more accurate and then more complete, whereas this one is probably faster, right?
I think it would also help in later on,
identifying knockoffs. So if you have human beings, they can tell it's an Adidas or an Abibas by the number of stripes.
Yeah.
So it's useful to have more humans in the loop than just let the AI do it.
Yeah. Okay. I like it. No, I think we're good on shoes. Oh, that was a very thorough. We answered several strategies on shoes. One more. This one's pretty straightforward too. Tagging uploaded photos. You can either make a friend or stranger do it, or you can do it yourself. Up to you.
Well, let's give mine.
That's totally fine. That was a valid strategy.
So a metric would be, so there are a number of ways to do this. One could be checking how many times a user relabels the picture, either edits the name or reshuffles the location of the picture.
Okay, so we're talking about a high-level strategy here, which is good. Mm. What's the metric?
So whether the classification was correct.
Okay. So we're going to use precision, we're going to use recall, we're going to use accuracy. What are we? F1 score?
Basically a percentage of correct placement.
Okay, so accuracy.
Accuracy.
Okay.
And the data we would collect is how many times, the number, the counts of user relabeling or shuffling the pictures.
Okay. So the data that's being collected is, people changing labels, and then we can imagine that, I think pretty straightforwardly, being turned into a computation of accuracy.
Yeah.
So this is implicit feedback you're getting from the users using your system. Again, I think you're going to have to account for noise or whatever, people just ignoring the labels or whatever. But I think that's one of those strategies, and that's probably better than crowdsourcing because the crowdsourced people aren't going to know who my friends are, for example. Okay. I think that captures a lot of the kind of key high-level options and gave us a chance to practice the thing. So how do we do that? Well, one is we actually don't monitor model quality alone. Typically, they're going to be monitored with other system attributes that we care about, things like uptime. I've been showing you these dashboards, and one is response rate, right? And one is a proxy metric for something, which is user rating. And the goal here is to set up automatic alerts with this quality evaluation. So things like when model quality drops, or maybe when response time goes too high. You want to look especially for jumps after releases so that you can roll back if a model does a bad thing. and also to watch for slow degradation, which can happen with stale models, data drifts, and so on. The goal is also to make it reasonable to debug important problems, to make sure that you're monitoring sort of key characteristics of the requests. So how do we do this? Well, the thing I keep showing you is Grafana dashboards. I don't know if they're still open over here. Oh, they are. Cool. But of course, the UI here sucks. All right, here we go. So Prometheus is a time series database and monitoring system. It's actually pretty old at this point by technology standards. I think it was SoundCloud that first built it, but now it's one of those CNCF projects that's sort of, kind of standard cloud native computing foundation kind of things like Kubernetes, right? So the idea is it's a framework that gives you pull-based metrics collection. You can expose your services via a metrics endpoint, and it's going to pull from those. And it does it on a schedule. So it's typically, you set it like every 15 or 30 seconds. So that's like, it pulls the data. And the basic data model is of a labeled time series. So every metric has a name and a set of key value labels. It gives you a query language. It basically can aggregate things into counters, gauges, histograms, and summaries, right? So it's going to be pulling data every 15 or 30 seconds, and you want to then see summaries of it. Grafana is a visualization and dashboarding layer that sits on top. Okay? So Prometheus is building a big database of data, and then you just got lots of data, and then we want to make pretty visualizations. That's what Grafana does. So that's the two layers at hand. It does not collect any data itself. But it does do a nice job with real-time dashboards. It makes it easy to set up alerts. It does auto-refresh. It's very nice. Okay, so those are the sort of, there are other technologies that do this in the space, but there's a reason these are kind of bog standard, and the reason that we're using them, it's helpful. So I will go back to my slides, assuming I can make this play nice. Ha, it worked for once. This is, movie log. But there are actually lots of commercial solutions. This is Azure's machine learning dashboards. It is interesting because it's combining system health, so operational health, things like response time, along with dashboards about model accuracy. They have this key distinction between data errors and system errors. Right? So you need to be checking both your infrastructure and whether the model is accurate. So although we're kind of saying, how do you evaluate model accuracy in production? It's all actually kind of continuous detection of system health versus lack of health, and it's not just on model accuracy. One thing I want to say about Prometheus, it's designed for more operational metrics, not things that are very high cardinality. Which means that it's much better for aggregate signals than it is for logging every prediction data point in any particular system, right? It's good at aggregating things. And so if you need to have very high granularity data detection, you're going to want to use a logging framework for that, to log everything. And you want to use Prometheus to do collection of metrics that are things you'd want to visualize in a dashboard or aggregate in a histogram or a count or something like that. Okay? Where am I at? So there's many different things you can do here, right? Things like detecting drift, depending on where you deploy your monitoring, right? You can look at things like distribution of labels of your training data. You can look at the schema and distributions of requests, distribution of predictions, quality of predictions, and so on. Here the point is that you can track distribution of predictions in something like Prometheus using histograms, right, or counters without having to track every individual prediction log. So you can track accuracy over time. You can track confidence over time, right? Maybe you have a threshold. If confidence is less than 0.75, then increase the counter. And you can see is the model becoming less confident over time, more than you are logging every individual data point. This should smell familiar. If you don't have ground truth, there are still things that you can assure with telemetry. We were talking about stuff like this when we first started talking about model accuracy. You can check, for example, agreement between multiple sensors. This is basically bog standard in autonomous driving contexts right now. You can use physical domain knowledge to define assertions or invariants. You can use domain knowledge about unlikely events. So it's very unlikely that you're going to have 3 cars in the exact same location at the same time. You check things like stability. You can check things like input conforms to schema, right? And basically all of the invariants we talked about from the model quality lecture. These are often things that you can check with telemetry and monitoring in production. Another reason to do telemetry is not just to tell when things are going wrong, but because you can end up using telemetry and logging for training, which contributes to what I think Amazon originally dubbed the ML Flywheel, right? That the more users you get, the more data you get, and the more you can train. So the point is that it's important also for sort of strategic business advantage and not just making sure that your models don't suck over time. Yes. So there are challenges here. There are sort of big ones. The first one, I'll just go through these kind of in order, right? The first one is data volume and operating cost. So if you think of something like Google Translate, right? It's processing something like 100 billion words a day. You can't just log them all, right? That's not going to work. So there's sort of, you can either sample or you can summarize, right, to solve this problem, and both have trade-offs. So sampling means you're keeping like 1% of all requests at random, at some definition of random. This is nice because you have realistic data. You can reconstruct full queries. Less nice because random sampling means that you're probably missing the rare stuff, which in some contexts matters a lot. Summarization reduces data by taking extracted features rather than the raw data, and you'll do that on the client side versus the server side. So maybe you can log 50% of all requests, but you're throwing away data in doing it, and so you won't be able to reconstruct all features of the data set. This is appropriate sometimes. It's also better for privacy preservation, I think, for maybe obvious reasons. Doing things on the client side reduces bandwidth and server cost, but again, you can't reprocess raw data later, but it's also good for privacy. A second key challenge is isolating feedback for a specific machine learning component and its version. So most ML-enabled systems actually have lots of different models that are collaborating. This is especially a problem in modern agentic systems, right? Where you've seen some of those architecture diagrams where we have an agent that does this and an agent that does that and a RAG and a blah and whatever, right? Being able to track the process of a query or a user story through all of the different components and different models so that you can construct or reconstruct what happened or which model is doing badly is hard. You're nodding in a way that that resonates for you, and I think it should, right? The point here is that you need to make sure that telemetry is tagged with specific components at different parts of a request and specific versions. We'll be talking more about provenance and versioning later, but it's key here, right, in telemetry to make sure that you're keeping track of what version of a thing you're talking about, because often different pieces are updated not at the same time. I did talk a bit about bias sampling and rare events already, right? If you're just sampling, you're missing rare events. And of course, there are issues of privacy. And this is both a design tension. Privacy has always been a concern, I think, and the key principle is don't collect what you don't need. Everyone ignores this principle, but it is the good principle. Better telemetry will make for better models in the limit, right? But it's bad for privacy. So some concrete techniques include things like differential privacy over aggregated metrics, federated evaluation. It's not a thing we'll be really going into in this class, but that kind of thing can help you improve privacy. And there's lots of research going on in this kind of thing. So there are also systems related to privacy that have to be fully offline because of business context or use context. So for example, if you're downloading the Google Translate model for whatever language you need onto your phone, right, you're not doing live telemetry there if you're in airplane mode the whole time you're visiting a foreign country, right? You're just intrinsically not going to be collecting telemetry live. Or also something like medical devices or military industrial settings that don't have connectivity, right? My insulin pump makes predictions about how much insulin to give me. It has no way to phone home and tell anybody how right it was. And so thinking about how to do that, right, in ways that are actually practical in those contexts is driven by use case. In this case, actually, one can optionally use a phone to track data and sync with an online database. I actually don't know if they're doing this, but it is something they could do. But if I'm only using the pump, they're SOL in terms of telemetry. If they convince me to also use their app, maybe there's a way that they can collect and learn from predictions versus accuracy over time. Surprise fun, we get to do 2. So what are the engineering challenges here? This one won't be as long because I don't think it, well, one, you already have it in your heads. You can update Slack, but let's talk for 5 minutes, and then we'll torture you again, and then we'll move on. I think this is the last breakout for the day. All right, let's bring it back quick. Let's just do one group per my front right. Tagging uploaded photos. What are our concerns here?
Track of, like, I would assume it's tracking people's faces and doing some sort of facial recognition to connect people to one another, so it could have this implicit understanding of people's relationships with one another.
Yeah, there's a lot going on there, right?
Yeah.
Like we're like recognizing people and somehow figuring out the nicknames that I use for my children, right? That's weird. Like there's a privacy concern. Is there anything else?
I guess for like rare events, then I don't know how you could like mix up data and start tagging people, like totally random people that you never exist in your life, and that could be a sign of data integrity issues because it's now able to pull data from other people's galleries and then tag your photos with that.
Okay, so there might be some concerns about data integrity that'll be hard to catch if we're just sampling. We weren't referring to bias in the same way, but actually one issue that can come up a lot with image recognition is bias, like racial bias or models performing much better for people of certain ethnicities than others. And the way that demographics work, depending who your users are, right, you might not catch those as easily. So being careful that you're doing stratified sampling might be important there. Okay, keep going, Christian. Zoom. Zoom is in the back, the same side. And I'm trying to make it easy for you.
We are not Zoom.
They're not Zoom. One more back. Zoom. Zoom, Zoom, Zoom. Sorry. I love how much you guys hate talking to me.
So for the cost, we think that like manually annotating the meeting notes is expensive, and like automated methods can reduce the cost but may sacrifice some qualities.
Yep.
Yeah, and
so there's some concerns about the cost of labeling in this situation, or the cost of the data collection if we're doing, humans have to watch all these meetings and then write summaries. Another one comes up for me there too, which is, now you're sharing everybody's meeting notes with strangers. So there's another privacy issue. Thank you. Another one for cost is, if you have to keep all those videos and all those predictions, right, that's a cost thing. If you're only saving summaries in that case, well, that's the problem in the first place. So, so actually, I think there are a lot of engineering issues with the Zoom AI issue. Like, how do you do this in a way that's not sucking up all the hard drives in the universe? Personalized playlists. What are our... How are we doing that?
Take the microphone and give it somebody else.
At least now we've put the social discomfort on you all instead of on us. We are distributing it. You are sharing our load.
So for the personal list, as an Asian, I use Spotify, and sometimes they only recommend Asian music for me, so I feel some kind of offended sometimes for them. So that would be one of the examples for biases. So yeah.
So sure. So it does speak to bias in the model, or it's being sort of pushed in a weird way. If we think about that impact on telemetry strategy, right? you want to think about, well, okay, so how are we going to make sure we catch that, right? Maybe not your offense per se, although that is important, and we'll be talking about biased models in the sort of traditional sense in a few weeks, but in the sampling bias, right? We want to make sure that we're capturing these instances appropriately and stratifying maybe over users, so informing how we sample or summarize, and maybe having some telemetry to tell when the user is very unhappy. Fair. And how about front left, Amazon, just to be complete?
So one of the things we talked about was in our metric, it was about if it recommends or if it shows a shoe when you take a picture, and it shows you which shoe that you're supposed to buy on Amazon, and it shows you a preview, and then we were trying to see if they click on that, then that indicates that it's showing the right sort of thing, and that if they add it to their cart, then even better, but that has all sorts of issues with privacy because now you're tracking their clicks, you're tracking their engagement and what they buy, which is
coming from the world.
Yeah, things, even other things in the picture that aren't just the shoe. So there's a lot of things to think about in that. And then in terms of cost, we didn't really think there was that much cost associated with that. I think that's one of the things we were unsure about. And then rare events, we were thinking about sometimes people have DIY shoes or shoes that aren't listed on Amazon. So how is that being handled? And yeah, bias. I don't know. That's another thing we were a little bit unsure about. Maybe it's there's an issue with high-end shoes, or what was the other thing?
Yeah, I mean, I think in this context, when we're talking about bias, we're worried more about biased sampling, right? Making sure that we're collecting rare events appropriately. Yeah. So I think for the shopping app question, right, there's sort of an interesting deployment question too about summarization on device versus on the server, right? Maybe you can do a little bit of image processing to crop out everything but the shoe, right? And then maybe that makes things a little better for privacy, for example. But you have, again, lost some of the data, right?
Do you think Amazon cares?
No, I do not. But I think if Amazon did care, they could do this. They're just choosing. That's the thing. They're choosing not to. Anyway, I love that I've invented a Amazon thing. So I'm not going to spend too much time on this, but this is something that we have been touching on in our discussion so far. Right? When we were talking about model accuracy earlier, some of your answers were actually much closer to system qualities, leading indicators, and user outcomes. I liked the Zoom conversation we had earlier because 3 different answers were one was very close to model accuracy, one was very much a proxy measure, right, and one was kind of in the middle. And the point is that you can use telemetry to measure system qualities and leading indicators and user outcomes, and operationalize those as well. So this is a kind of framework or way of measuring things that can help you with all of those things. So we are not doing that. We're going to instead talk about experimenting in production. Now that we have all this data, we can do experiments with it, which is cool. So A/B experiments are now bog standard in any kind of non-trivial website you're using, I think. Bless you. Not just with ML. But the point is that anything where usage is observable online, you can use telemetry, you can do testing in production, right? So the key idea here is that you can randomly assign users to treatment and control groups without them knowing it, and then analyze small individual changes while keeping everything else constant. Google rather infamously tested, 36 different shades of blue for ad links? It was in the 30s, right? By doing this, by showing a very small slice of their users, versions of the google.com website with different shades of blue for the ad links to figure out what the ideal shade of blue was for click-through rate. Bing has a fairly dramatic kind of example here where they were checking about where to put the ad display, to put it in the link versus under the link. It was implemented and A/B tested in production, right? So the difference here is that this text, do we put it below the link or do we put it with the link? Within 2 hours, the revenue too high alarm triggered, which is usually bad. It usually means they're accidentally double billing or something like that. But in this case, there was a massive increase in revenue and didn't hurt their various user experience metrics. So the key thing here is, I mean, certainly for ad placement, you need to measure more than just how much money you're making, because it's very easy to make a lot of money with ad placement by just making everything an ad. So note that they are tracking both user experience and ad revenue. But the way they do this is by slicing their users and experimenting on us all. Right? I actually, personally, am mostly OK with this. That's fine. And so there's lots of options for this makes sense for ML components, right? Like new product recommendation algorithms, new language models, new models to detect things on a smartwatch, right? It does require careful provenance and version tracking, right? So there's engineering considerations here. But it's the same kind of thing where you can test out a new feature on a small segment of your user base. But there are some actual engineering questions, right? You need to have alternative versions of the system that are implemented. One way to do this is in code, right, in the implementation using what we call feature flags. The other way to do this is in separate deployments. So the random sampling is dividing people into groups at your load balancer. You need to map your users to the treatment group. There are a bunch of different ways to do this. You can do this randomly. You can do this using services. And then you need to monitor outcomes per group using telemetry to make decisions. So feature flags, you may have seen these in your internships, right? Feature flags aren't only used for A/B testing, but it's one way that you can do it. Is you can say, if this feature, you have a Boolean flag that says, if this feature is enabled, show it. If not, don't. You need to have an external mapping of flags to customers, so who should see which configuration, right? So one way to do this is, pick a random number, show it to 10% of your users, but you need to be doing the tracking somewhere. This, like everything else, can be done as a service. There are companies that do this. These libraries can get complicated. If you want to do a factorial design, the Bing team wrote a whole book about how to do it. But that's the way that kind of thing is implemented. Point is, there's code for this, as is true in so many things. Christian, would you rather I get to chaos experiments and canary releases, or do you want me to do stats?
Do stats very briefly, because I need this in the homework.
Okay, darn. OK, so what I have said is there are different mechanisms for mapping users to groups, right? I want to take 10% of the classroom and show you all ads in one shade of blue, and 90% of the classroom sees the original shade of blue. And I need to see if the 10% of you with that shade of blue buy more things than the 90%, right? This is a statistics question. Right? So what's the, I say I did this. What's the problem? What's the problem?
There is a severe difference in sample size.
There is a very large difference in sample size. So that doesn't mean that this observed difference is not meaningful. It might be, right? But just because the average is different doesn't mean that it is meaningfully different. And it means that it doesn't mean that it wasn't just by chance, right? And that's the key problem, is that you need to be able to say if this observed difference is likely to have been the result of bad luck in your sampling versus actually a difference between the two populations. So the t-test is one of the standard tests for this kind of thing. 10 users is probably too small for it because it assumes a normal distribution. And apparently you can ignore the normal distribution with enough data points, but 10 is a very small number. So if we can talk about stats really quick, right? All data in the world has some kind of distribution. When we draw samples from the same distribution, you can get different samples just by accident. Right? If I happen to pick 3 random people in this room on this side and 3 random people in this room on this side and measure your heights, I can pick by accident just 3 super short people over here and 3 super tall people over there. right? Even though you're all drawn from the same distribution of 20-something humans height-wise. So statistics tells us whether interesting patterns likely actually exist in the samples or whether it can be attributed to sampling noise. And that's what we're trying to get is like a confidence interval that says if we can compute the average of some samples, what's the average of the population of that whole group, right? Or what can we expect? And that's what statistics is going to let you do. Significance testing can help with comparisons. So if you have two confidence intervals that says, hey, what can we expect the actual average of this population to be of two samples? If they overlap by a lot, then you don't have that much confidence that they're actually drawn from different distributions. Whereas if they don't overlap very much, like here, right, then they probably are drawn from different distributions. The important thing here is like a p-value of 0.03 doesn't mean there's a 3% chance that the difference is due to chance. A p-value of 0.03 means that if there were no real difference, we'd see this difference that we have observed only 3% of the time, which is still not very likely, right? But you just want to think about what the thing actually means. So it doesn't tell us the probability of our hypothesis being correct, because a p-value is assuming a hypothesis, right? And telling you how likely it is that you'd see this if that hypothesis were true. So that's what the p-value does. It gives you a not a confidence, but a likelihood that can help you reason about the observed difference and whether or not it's likely related to the thing you're trying to measure. There are lots of ways to do this. I'm not going to step through them, except to say this is actually a useful slide. So if you assume comparing normally distributed groups with the same variances, if your numbers are big enough, it's fine. You can use it on things like model accuracy or human click streams. It's more sensitive and powerful. You can use non-parametric tests if you cannot assume a normal distribution. That's true for very small data sets and also categorical data like Likert scale ratings. Was that enough on statistics? OK, good. Oh, but there is a useful decision tree. I'm not going to step through it, but if you're like, I don't know what I should use, remember this slide. Just use a t-test. But I don't know, maybe they'll go off into the world and they're like, try to figure out what test to use. And like, I remember that Claire said there was a slide, and then they can come find it. But actually, just use a t-test, it's fine.
Unless you run any experiments at the same time, then read a book.
Yeah. All right.
T-test is enough.
Just use a t-test on the whole thing. Yeah, I don't know about your other classes. We're not speaking about them. I'll just talk about chaos experiments quick, and then we'll call it a day. I hinted at these, I forget, a couple lectures ago. I kept the Simian army on here because they were really, Netflix was the pioneer of this model. These days, including for ML systems, there are more modern frameworks like Litmus or Gremlin. The point is you're deliberately introducing faults in production to test the robustness of the overall system. It's not specifically about ML as a concept, but it's about testing production robustness. So thinking about how you would do that for ML components, I think is a worthy exercise that I leave you to undertake on your own time, because it is 3:20. And so that is my last thought for the day. But that was almost all of them, because there's only like 6 more slides. Here's advice for experimenting in production. Christian can talk about it on Wednesday. Enjoy M1.